Howdy, today for Flipping Science, we're going to do some titration questions.
We're doing some good titrations. We're doing some calculations. We're doing some good titration. Good titration.
So science understanding that we're going to look at, knowledge of mole ratios and reactants can be used to perform quantitative calculations. So perform stoichiometric calculations when given the necessary data, and determine the concentration of a solution of a reaction in a chemical reaction using the results of titration. The first part, we're going to use the titrations as our example of using stoichiometric ratios to help answer questions. So here's the first question. Jimmy is titrating 20 mils of 0.1 molar sodium hydroxide against a hydrochloric acid solution of unknown concentration, and we have a set of results. So the first step is we need to figure out what the titer is for each of those sets of results, and then we need to figure out what the average titer is. So I'm going to use my calculator to help with my subtraction. When you're figuring out the titer, you take your big number, and from that you subtract the small number. And that's the easiest way to do it. So I'll get my calculator up. So we have 21.82 minus 3.75. So my first result is 18.07. So now I'll do the rest of the results really quickly. So there's my results. If I have a look at my results, I've got probably 4 that are concordant here within 0.1 of a mil of each other. So I'm going to use all 4 of those results to calculate my average titer. This first result is probably the ballpark, so that's the one that you do roughly to start with, and then you use the other ones as long as they're within 0.1 of a mil of each other to calculate your average. So to figure out the average titer, so that's going to be our volume of hydrochloric acid, V hydrochloric equals 17.88 plus 17.95, 17.97 plus 17.95, and we're going to divide that by 4. So now I'll go to my calculator. So I get 17.94 if I round that off. 17.94 milliliters, and that equals 0.01794 liters, and that's the number we're going to use when we do our calculation. So now, given Jimmy's average titer, calculate the concentration of the unknown hydrochloric acid solution. So first thing I'm going to do is I'm going to write out the reaction equation. So we're reacting hydrochloric acid with sodium hydroxide. Acid plus base goes to salt, so in this case it'll be sodium chloride plus water. So this is nice because it's an easy one-to-one ratio of acid to base. Next thing we're going to do is write down what we know. So we've got the volume of sodium hydroxide. If we look back, we can see the volume of sodium hydroxide was 20 mils. So 20 milliliters, which is 0.02 liters. And our concentration of sodium hydroxide, if we look back, we see the concentration was 0.1 moles per litre. Alright, now we've got a volume and a concentration, we can figure out a number. So we'll use our equation. So CNV, I'll make my magical triangle so I can remember the bits of it. So C equals N on V. So we've got C and V, so we can figure out N. So the number of moles of sodium hydroxide equals C times V equals 0.1 times 0.02, and I can see that's going to be 0.002 moles. So now that's how many moles of sodium hydroxide we had down the bottom in the conical flask. Now we've got that number of moles, we can figure out how many moles of hydrochloric acid we had. If we look up at our reaction equation, we've got a one-to-one ratio between hydrochloric acid and sodium hydroxide. So my number of moles of hydrochloric acid that neutralize that amount of sodium hydroxide has to be the same. So my ratio of hydrochloric acid to sodium hydroxide is 1 to 1, and therefore my number of moles of hydrochloric acid is going to be 0.002 mole. Now we have that. The other thing we have is our volume of hydrochloric acid, because that was our average titer. That's what we were putting in the burette when we were doing the titration. So my volume of hydrochloric acid is my average titer, which was what we calculated here, 0.01794 litres. So 0.01794 litres. So now I've got a number and I've got a volume, so I can figure out a concentration. So concentration equals, if I look at my magical triangle, N on V, so my concentration of hydrochloric acid is equal to my number of moles, which is 0.002, divided by my volume, which is 0.01794. And I get my calculator up, so get 0.002 divided by 0.01794, and that equals 0.011 moles per litre. So 0.011 moles per litre. So here's another question. Tallulah is titrating 25 mL of 0.2 molar sulfuric acid against a potassium hydroxide solution of unknown concentration, and here are her results. Again, we're going to calculate the titers for each of her results, and then we'll calculate the average titer. So I'll bring my calculator up and I'll do this really quickly. So there's my results. If I have a look at my results here, I can see I've got 3 that are within 0.1 of a mil of each other. I've got my ballpark out the front here, and I've got another one that's a little bit out. So what I'm going to do is I'm going to indicate which ones I'm going to use by crossing out the ones I'm not going to use. So I'm just going to put a big cross next to the ones I'm not going to use, so then I can see which ones I'm going to use for my average titer. So my volume of potassium hydroxide is going to be equal to the average of the 3 that I'm going to use. So 12.85 plus 12.92 plus 12.92. And I'm going to divide that by 3. So go back to my calculator. And I get 12.896, so 12.90 rounded off. So 12.90 milliliters, which is 0.01290 litres. And that's my volume of potassium hydroxide that I'm going to use. Next step says, given Tallulah's average titer, calculate the concentration of the unknown potassium hydroxide solution. So again, I'm going to write down what the reaction equation is first before I do any calculations. So I'm reacting sulfuric acid with potassium hydroxide, so H2SO4. Now my salt is going to be potassium sulfate, which is K2SO4, and I'm going to get water as well, H2O. Now I've got 2 potassiums here and only 1 potassium over here, so I'm going to double that to balance it out. Make sure the rest works, so 2 Ks, 2 Hs, 1, 2, 3, 4 Hs, so I'm going to need to have 2 water molecules as well. Alright, so now we can write down what we know. So if we go back to the question, we can see that the volume of sulfuric acid is 25 mils and the concentration is 0.2, so we'll write that down. So turn that into litres, and my concentration. Alright, so now I can figure out my number of moles of sulfuric acid because I've got the volume and concentration. So NH2SO4, and I remember from my magical triangle before, N equals CV. So concentration is 0.2, and my volume is 0.025. And I'm just going to go to my calculator to check the answer I think I know in my head. So we've got 0.2 times 0.025, that equals 5 times 10 to the minus 3. 5 times 10 to the minus 3 moles. Alright, now I need to look at my ratio between my sulfuric acid and my potassium hydroxide. So it's a 1:2 ratio. So ratio sulfuric acid, potassium hydroxide equals 1:2. What that means is my number of moles of potassium hydroxide has to be twice the number of moles of my sulfuric acid. So it's a 1:2 ratio. So it's 2 times my number of moles of sulfuric acid. Alright, so it's going to be 2 times 5 times 10 to the minus 3, which is, just go back to my calculator to check my answer, I think I know, times 2, I get 0.01. So 0.01 moles. So now I've got my number of moles of potassium hydroxide, and I also have my volume of potassium hydroxide, which I calculated back here. So my volume is 0.01290 litres. So volume is 0.01290 litres. So now I've got number and volume, so I can figure out concentration. So concentration of potassium hydroxide, C equals N on V, equals 0.01 divided by 0.01290, and that equals 0.1 divided by 0.01290, and I get 0.7, and round that to two significant figures, 0.78 moles per litre equals 0.78 moles per litre. So today on Flipping Science we did some example titration questions. That's it for Flipping Science today. See ya. 3, 2, 1. So the science understanding that we're going to look at, knowledge of mole ratios and reactants can be used to perform quantitative calculations. So perform stoichiometric calculations when given the necessary data, and determine the concentration of a solution of a reaction in a chemical reaction using the results of titration. The first part, we're going to use the titrations as our example of using stoichiometric ratios to help answer questions.